Namaskar, welcome to Exercise Explained. In this video, I will be doing question number 1, question number 2, question number 3 and question number 4 of exercise 1A, Measurement and Experimentation, ICSE 9th Physics. So starting with the first question, the wavelength of light of a particular color is 5800 Armstrong. So here the wavelength is given as 5800 Armstrong. Express it in nanometer. So we need to write it in nanometer and we need to write it in meter. So in order to understand this, I would write it here that 1 Armstrong, we write it this way, is equal to 10 to the power of minus 10 meters. So the value given here in the question is 5800 angstrom. So that would be equal to 5800 into 10 to the power of minus 10 meters. So you can definitely leave your answer here. This is definitely correct. But we will be proceeding towards the textbook answer. So in order to get the textbook answer, I would be dividing and multiplying by 1000. So that would give me 5800 into 1000 divided by 1000 into 10 to the power of minus 10. Now this 1000 in the denominator went for converting 5800 to 5.8. So we get this as 5.8 into this 1000 in the numerator can be written as 10 to the power of plus 3 into 10 to the power of minus 10. So this would give me 5.8 into 10 to the power of 3 minus 10, because the powers would be added and we have a negative power. So plus into minus gives me minus. So we get the final answer as 5.8 into 10 to the power of minus 7 meters. So this is the second part, that is the B part answer. We have got it in meters. Now the second part of the question says convert it into nanometer. So 1 angstrom we already know it as 10 to the power of minus 10 meters. Now 1 nanometer is equal to 10 to the power of minus 9 meters. Therefore, when we are converting from angstrom to nanometer, what we would be doing is we would be dividing by 10. If we are doing the other way around, that is nanometer to angstrom, we would be multiply by 10. Now since the question is given in angstrom, so we have it as 5800 Armstrong. So I would be dividing that by 10. So divide by 10. So we get it as 580 nanometer. So this is how we get it in nanometers. Otherwise, we can actually convert from this step also. That is, we have got it in meters. So we can get it in nanometer from there also. So there are options to do it. I have done it in this way. Getting into the next question, that is question number 2. Here it is given the size of a bacteria is 1 micron. So 1 micron is 10 to the power of minus 6 meters. Find the number of bacteria in 1 meter length. So it is a very simple problem actually. So before doing it, I would write 1 micro is equal to 10 to the power of minus 6 meters. Now one bacteria, the length of one bacteria is this much. So the total length given here is, I would write total length is given as 1 meter, and this is length of one bacteria. Therefore we can write number of bacteria is equal to total length divided by length of one bacteria. So now we can actually write the total length as 1 meter divided by length of one bacteria. We just got it in meters as 10 to the power of minus 6. So the number of bacteria is going to be 10 to the power of plus 6. So the number of bacteria is number of bacteria is 10 to the power of plus 6. Getting into the next question, that happens to be the distance of a galaxy. So the distance is given as 5.6 into 10 to the power of 25. It will be meters here. I forgot to write meters. I would write it here. So 5.6 into 10 to the power of 25 meters. Assuming speed of light, so speed of light is given as 3 into 10 to the power of 8 meter per second. Find the time taken by light. So we need to find the time taken by light to travel this distance. So this is a 6th standard problem, I would say. Speed is equal to distance by time. We can use the formula. Speed is equal to distance divided by time. So from this formula, since we need to find the time, we can write time is equal to distance divided by speed. So the time happens to be, distance is 5.6 into 10 to the power of 25 divided by 3 into 10 to the power of 8. Before doing calculations, please check whether the units given are in SI unit or not. In this question, everything is in SI unit, so we need not convert anything. So 10 to the power of 8 goes to the numerator. We get 5.6 divided by 3 into 10 to the power of 25 into 10 to the power of minus 8. So 10 to the power of 25 minus 10 to the power of minus 8. So we get it as 5.6 divided by 3 into 25 minus 8 will give me 10 to the power of 17. Now 5.6 divided by 3 gives me 1.86. So we get it as 1.86 into 10 to the power of 17, and the SI unit for time is seconds, so we will get it in seconds. So that would be our answer for this question, that is 1.86 into 10 to the power of 17 seconds. Getting into the next question, that is the wavelength of light is 589. So wavelength is given as 589 nanometer. We need to find the wavelength in Armstrong. So as we had discussed in the first question, whenever we are converting nanometer to Armstrong, we multiply by 10. So here 589 into 10 would give me 5890 Armstrong. So this completes 4 questions for this video. The next 3 questions would be there in the next video. I would be solving it in the next video, the link for which will be provided in the description. Do check that out, and if you like the video, do share it with your friends and consider subscribing to the channel. Dhanyavad.